name is Ann Berg. I'm a research professor at Northwestern Feinberg School of Medicine and the Ann and Robert H. Lurie Children's Hospital of Chicago. And I'm really delighted to be here today as part of your RX Virtual Hope series. I'd like to thank Leah Schust and Families SCN2a for inviting me, and I hope we'll learn a little bit about the concerns in doing clinical research to help support randomized trials and bring new therapies to children in great need. First of all, let's define a little bit about what research is. Research is the systematic investigation into and studies of materials and sources, people, and treatments in order to establish generalizable knowledge and to reach new conclusions. That sounds a little bit opaque, but I like to think about research as taking a trip. If we're going to take a trip, we don't just say, let's go. We actually have to ask some questions. Where are we going? What time of year is it? What kind of clothes should we bring? What is the purpose of the trip? How are we going to get there? What are we going to do while we're there? How long will we be there? Where are we going to stay? And how will we get around while we're there? Because ultimately, these questions are very important. If we're taking a business trip to Paris versus a bucket list trip to Machu Picchu, we're going to prepare very differently and bring very different equipment and clothing. Ultimately, taking a trip is expensive. It takes a lot of time, a lot of energy, and it's not easily to redo. So we want to be prepared for success. We don't want to be skiing when we go to Paris in spring or have our scuba trip equipment with us when we go to Machu Picchu any time of year. Research is a bit like taking a trip. We may not talk about destinations and modes of transportation, but we do talk about purposes, goals, hypotheses, design, data, analysis, databases, IT infrastructure, data quality, regulatory concerns, and collaborative agreements. We're not going to talk about all of those today. That would take years, really, to cover fairly. But I would like to touch on some important aspects that I think are important for you as potential study participants to understand. First of all, the purpose or goals of hypotheses of research are highly varied. We may want to describe a rare condition. We may want to describe what current treatment practices are. Or, ultimately, we may want to test the efficacy of a new treatment so that we can bring it to other patients. Here are a few examples. This is a survey that was done by the Dravet Syndrome Foundation to find out what concerns, in addition to seizures, parents had. And this survey highlighted the huge number of children who have gait disturbances, hypotonia, seizures at night, and other issues as well. This was a study, a research study that used a Delphi Consensus process to determine what the optimal therapeutic approach was for Dravet syndrome. And I should point out that while the study was very successful in coming up with an algorithm for first, second, and third line treatments, it was done just before two new therapies came out, fenfluramine and cannabidiol, and this actually has to be updated. And that's something that is important to realize, that research evolves as knowledge evolves, and it's a continuing process. Finally, probably the most exciting piece of research is the randomized clinical trial. And this is the kind of study that is used to provide evidence that a treatment actually can work. The randomized trial starts off with a group of study patients. They are assigned to treatment conditions through a process called randomization. Colloquially, we can liken that to flipping a coin. Patients receive either a new therapy or a standard therapy or perhaps a placebo therapy, but some sort of comparison therapy. They are followed for time to determine their outcomes. And in trials of seizures, the most common outcome is a 50% reduction in seizure frequency. So we look to see how many people in the new therapy group versus the standard therapy group have that reduction. We do the analysis, and based on that analysis, we determine whether or not the trial supports the efficacy of this new therapy. Randomization is an important component of a trial because what it does is assure that people who get the treatment versus those who get the comparison treatment are pretty much the same within random chance variation. When we compare the outcomes in these two groups, we can be reasonably certain, very certain, that any differences in outcomes is due to the differences in treatment and not due to the patients who got the treatment versus the comparison being different. We could do almost a randomized trial without randomization. We could take a group of patients and just see which treatments they get. Some get a new therapy, some get an old therapy, or maybe don't get an additional therapy, and then we could look to see how they did overall. And do the same analysis, and it would be exactly the same except for the piece where here we randomize, we're the ones who decide by random, and here something else is making that determination. Otherwise, these two studies could be identical. Whereas in a randomized trial, where these two groups, though, the treatment and comparison group, are almost identical, in an observational study, we have no control over that, and it is quite possible that those who receive treatment vary substantially from those who do not receive treatment. For example, those who receive treatment might be healthier and more willing to take a risk on a new treatment, and those who are sicker may not. Consequently, when we compare the outcomes in these two groups, we're not always sure if any differences in outcome are due to differences in treatment, or maybe it's because the patients were different to start with. Randomized trials give us efficacy, the performance of an intervention, a new treatment, under ideal controlled circumstances. And the reason we do it is that anything we find in a randomized trial gives us the confidence that the differences are due to treatment effects and not to other factors. Randomized trials are needed to get FDA approval. Now, I want to take just a moment, and I'll come back and forth to this point in a little bit, but I do want to emphasize that randomized trials give us efficacy under ideal, tightly controlled circumstances. They don't tell us everything about how a treatment works, and sometimes a randomized trial is not the best way to find that out. But in the real-world situation, we're really interested in, does the treatment work for everyone or for other people? Does the treatment work specifically for my child? Your child might have an SCN2a variant. Cannabidiol was tested for children with Lennox-Gastaut syndrome and for Dravet syndrome. We don't know based on that study if it is helpful for people who have SCN2a mutations. What about other outcomes? We know it worked for seizures in those groups, but could it improve dystonia? We have no idea. Is it feasible to do in the real world? And is it widely acceptable? And not all therapies are feasible or widely acceptable. Doing a randomized trial involves a lot of work, and it's really a voyage. Who are we going to study? What exactly is the treatment? How long will patients be followed? And what's the outcome? What are we trying to make better? So when we do a randomized trial, we have to determine who are we going to study. This isn't a simple question. Are we going to take new onset patients, patients who have already failed multiple medications? Are we going to include infants or children or adults? Are we going to include gain of function or loss of function? There are a large number of questions that have to be answered, and those questions, the answers to those questions, limit how the information can be used for effectiveness of the study, because we're only focusing in on a very narrowly defined group. Children have to be randomized. That's often a statistical and pragmatic issue. There are issues concerning how the treatment will be administered, the route, the target dose, when, with food, without food, a whole host of questions. And then how long will they be followed? Is a week enough? Do we need to follow for 3 months, a year? And what is the outcome that we're trying to have an impact on? Is it seizures? Is it behavior? Is it dystonia? Is it sleep? How are we going to measure that? And how are we going to know if we've really had an effect? Because in the end, we do our analysis. And either the trial shows that the treatment was efficacious for the endpoint that we said we were going to study, or it fails to support efficacy. There's no redo. This is a huge amount of work that has to go into doing this trial. We want to give it our best shot. I should also mention that these trials are done within a global context of ethical and safety concerns as well. Randomized trials have a laser focus on efficacy. A huge amount of preparation and knowledge about the disease, its natural history, its outcomes, has to be known before you ever consider doing a trial. Observational studies are the way that we get that information. We can ask a wide range of questions that cannot be asked or answered in randomized trial. There is a large variety of designs available, and observational studies are the way that we get descriptive information, natural history, data, instrument design, all of those factors that inform trial design in the end. This is essential. Now, we talked about randomized versus observational. Within observational, there are several concepts that I want to mention. Retrospective versus prospective, cross-sectional versus longitudinal, and then opportunistic versus systematic data collection. Retrospective versus prospective is really just a matter of perspective. Retrospective means you're studying the past. By the time you are studying something, everything has happened and you don't have to wait for anything. It's like looking in your rearview mirror. Prospective means that you move forward from today into the future. Retrospective studies have the advantage in that they're fast and less expensive. You don't have to wait long to do them. You're looking at things that have already happened. Prospective studies, by contrast, are longer to do and much more costlier. Retrospective studies, though, have a lot of disadvantages relative to prospective. The information that you're interested in may never have been collected in the first place. In a prospective study, we ensure that we put plans in place to collect the information we're interested in. Retrospectively, information may be collected, but it may be incomplete. Prospectively, we deliberately ensure data completeness. Retrospectively, the data may have been collected in a very non-systematic manner without any protocol. Prospectively, we assure systematic data collection under a protocol. By the same token, there can be a lot of loss to follow-up in a retrospective study. We minimize that prospectively. And I think I've already said this, the data collection is highly variable, and very importantly, it can be really subject to a variety of potential biases, all of which we avoid or minimize prospectively because data is collected in a way that is just as rigorous as for a randomized trial. And of course, all randomized trials are prospective. Another concept is cross-sectional versus longitudinal. Cross-sectional studies are done in such a way that measures are made at one point in time. Longitudinal studies, by contrast, involve measures that are made repeatedly in the same person over time. Cross-sectional studies are good for the description of current events. Longitudinal studies are much better for charting the course of an event or a feature over time. Cross-sectional studies are often used to infer change over time, but they're limited, and I'll give you an example. Whereas in longitudinal studies, we directly observe change over time. Of course, randomized trials are always done longitudinally. These are data that come from the family's SCN2a participation in the Simons Searchlight project. I'm sure you're all familiar with that. And what I'm going to show you are the receptive communication scores from the Vineland Adaptive Behavior Scales. Now, when people first participated in the study, you filled out the Vineland, and these are your data at cross-section at the point of entering the study. And what you see is the score from 0 to 100% of the score by your child's age, from 0 up to 25. And what I think you can appreciate is that the scores tend to go up with time, from very low, nearly up to 100% in a sum. But generally there seems to be a trend going up. But in a few patients, and maybe this one belongs in there too, it looks like they may not be. And what we cannot tell from here is whether these were children who were up here earlier and fell off, that there may have been a regressive component to this, or if these are just children who stayed low and followed a lower trajectory. So based on these data, we're a little bit worried about a possible regression in skills, but we never observed that. Many of you also participated in this study multiple times over the course of years, and these are the longitudinal data. And here you can see each of these lines represent data points from a single child. So this is a child whose parent filled out the Vineland at about 15 and then 16 years, 16 and 17 years. Here's someone who participated 3 times. And what we can see, even though the data down here are a little bit sparse, but what we can see is there's no evidence that there's anyone who's actually falling off. People are going up or staying pretty flat, plateauing. But there's no one who's really going downhill. So that's a little bit reassuring. It would be nice to have more robust data, but that's the difference between a cross-sectional approach versus longitudinal. The third concept I want to mention is opportunistic versus systematic data collection. Opportunistic data collection is what happens when people say, oh, I recorded all that stuff in my patient's records over the years, and someone like myself goes in and says, oh gosh, the data must be in here somewhere. And whether the data are piles of folders on a desk or these piles of folders have been scanned into the EMR, it is really difficult. The data are, you can imagine. By contrast, systematic data collection involves a deliberate plan from the start, and the data are neatly organized and they're designed to meet our specific study goals. Opportunistic is great. It seems like it's really convenient and it should cost less. I can tell you it can take a lot of time and a lot of energy to go through those piles. Systematic data collection will, from the get-go, require dedicated resources and can be quite expensive. The opportunistic approach provides uneven quality, usually. Systematic data collection means that quality control measures are in place, period. The opportunistic approach yields non-standardized data. Systematic yields standardized. We see a lot of missing data if we only use what's there opportunistically. And again, systematically, data completeness is monitored. All trials use systematic data collection. So what is needed to plan a trial for a rare disease such as SCN2a DEE? Remember, it's hard, it takes a lot of money, a lot of time, and a lot of energy, particularly for the parents. Whatever study we do, we want to be sure to give it our best shot. The FDA has been issuing a series of guidances over the last several years to help pharmaceutical concerns be prepared as much as possible to do effective trials. And in these guidances, they have outlined the importance of understanding the full range of disease manifestations, not just the seizures, for example, the need to conduct a study of sufficient duration so that you can actually observe a change if a change happens, and to know what a clinically meaningful outcome is. They've impressed the importance of focusing on life-limiting or life-altering aspects of the disease and formulating sensitive clinical endpoints so that you are able to know whether or not a change has actually occurred. This guidance addresses several important aspects of this diagram. It addresses the issue of who you're going to study, the meaningful subgroups, what the outcomes will be and how they will be measured, as well as the duration of follow-up. What I'd like to do is focus a little bit on these outcomes, and particularly the idea of a clinically sensitive measure. The example I'm going to give you is synthetic, that is, I made it up, but it's based on real conversations that I've had with many parents over the years. Sleep, I think you all know, is an aspect of the developmental epilepsies and encephalopathies that is terribly disrupted. I had a conversation once with 2 parents standing on either side of me, and we were talking about the many different concerns they had, and I asked, how is sleep? And simultaneously, in stereo, they trumpeted, horrible. My child never sleeps at night, wakes up every night, naps during the day. I'm exhausted. So what if we develop a therapy to help with sleep, and we decide that because these kids wake up every night, our therapy is going to be tested to see whether or not it reduces the number of nights a child wakes up. So our outcome is going to be the number of nights a child wakes up and the number of nights a child sleeps through the night. We conduct a beautiful randomized trial, and I'm just going to show you the after treatment effects. And what we find is that in the placebo group, as well as in the new therapy group, almost everyone is waking up 6 to 7 nights a week, and a few are waking up only 3 to 5 nights. There's no difference between the placebo and new treatment, and that's pretty frustrating. It means our therapy is not efficacious because it did not. Our study failed to show a difference in the outcome between the treatment and the placebo groups. In randomized trials, we often ask a global clinical impression of change type question. Is the outcome, in this case sleep, much worse, a little worse, about the same, a little better, or much better than before? And when we ask this question, parents in the placebo group were pretty much saying about the same. A few said it was much worse, some said a little worse, most said it was about the same, some a little better, some much better. But overall, no change. By striking contrast, in the new treatment group, we see a few parents saying it was about the same, a good chunk saying it was a little bit better, and over half saying it was much better. That does not reflect what our outcomes showed, that there was no difference. You probably know the answer to this because you live with this every day, but if we want to understand sleep in children who have severe epilepsy, we need to ask more than just, did your child sleep through the night? If we had looked at outcomes such as, how many times did my child wake up during the night, we would find that in the placebo group, there were children who were waking up 4 or more times. Many or most of the rest were waking up 2 to 3 times, and very few were waking up only once. By striking contrast, in the treatment group, most of the children woke up only once, and the rest woke up 2 to 3 times. None woke up more than 4 or more times. If we look at how much time children were awake, we can see that in the placebo group, there was a large chunk, 20%, who were up for 2 or more hours. A lot were up for 1 to 2 hours, and very few were up for an hour or less. By striking contrast, in the new treatment group, a lot were up for only half an hour or less, and the rest were up for an hour, half an hour to an hour. So huge impacts, but our measure of outcome was grossly inadequate to measure that. It was insensitive. So with that, I know there's a lot of interest in new therapies for many of these rare genetic disorders, including SCN2a DEE. And we have been working closely with Leah Schust and the family's SCN2a Foundation in planning an SCN2a clinical trial readiness study. And we will have a contest for someone to come up with a better acronym than that. The study will be prospective, longitudinal, and will involve systematic data collection. We've already begun to pilot some of the instruments in something that we called the ability study, and some families from SCN2a took part in that. And what we did was look at a series of instruments that were parent-reported, standardized and validated, and assessed critical domains: motor function, communication, social behavior, some self-care and activities of daily living, and challenging behaviors. We're at this point pretty confident that our measures are not going to be like our very ineffective, insensitive measure of sleep outcome, but will really reflect the concerns that parents have and will be able to show changes within the SCN2a group. I'm going to wrap up now and just mention some highlights, and that is that research, any research, has to be done with the purpose. The purpose will drive the design of the study, the measures that are made, and how the analysis is done. Yes, randomized trials are the gold standard for demonstrating efficacy. They require intensive planning and research before launching the trial. Observational studies provide a huge amount of information that can help ensure a successful trial. We will be planning this study shortly. Please keep an eye out for the SCN2a Clinical Trials Readiness Study, and thank you so much for your time and attention today.